So 2.1, B is in Bravo. We're on page 111 in 2.1, and we're beginning section B as in Bravo, solving equations by factoring. There are a couple things that I want to bring up. You have probably been doing this for years and years, but we're going to review some of this just to make sure we're all on the same page. Most of the equations that we're going to be solving in this section are called quadratic equations. And if you remember, an equation has an equal sign. And there's some things that are a little bit different about quadratics, but also the same as linear equations. So just to kind of give you a little bit of a review, linear equations this is a slope-intercept form, kind of in this format here, y equals mx plus b. There is an exponent of a 1 on the y and a 1 on the x. But that is it. There are no other exponents, which means when you draw a picture of this equation, when you graph it, you're always going to get a straight line. A quadratic equation is written in this form. And it's equal to 0. When it's written in this form, there's 3 different parts to it. Let's go over this. This is the quadratic part. It's called the quadratic term. This is called a linear term, and this is called a constant. Now, in earlier lessons, we were just looking at this. Notice the similarity between these two. This is what makes it a linear equation. This is what makes a picture a straight line. As soon as we add the quadratic piece to this equation, it takes away the straight line, and this tweaks that straight line to look like something else, which we'll get into what that looks like later. But this A here is 0 in a linear equation. 0 times this, x squared, makes this go away. So therefore, we're left with this, which is the straight line, because this is not there to tweak that straight line into another form. So all that to say, this form right here, ax squared plus bx plus c equals 0, is the standard form for quadratic equations, which means when we are doing quadratic equations, we are going to try to get them in this form right here. Ax squared plus bx plus c equals 0. Or another way of saying that, let me move this out of here because I've got all the scribbles on there. Ax squared plus bx plus c equals 0. The a, the b, and the c are numbers. They're constants. The x squared and the x will remain there. So when those are written as numbers, such as 3x squared plus 2x plus 4 equals 0, we replace the a, b, and the c with numbers, and then we solve for 0. Or I'm sorry, we solve for x with it equal to 0. The number 0 is a very special number when it comes to math, because if we set our equations equal to 0, then that means the left-hand side has to equal 0 because the right-hand side is equal to 0 because we have an equal sign. So what we're trying to do is figure out a number to put in for x that we will do the 3 times that number plus 2 times that number plus 4 and get 0. Makes our life so much easier because we have, and I know this will seem like this is not connected, but if we have a 3 and we have an x and we say that that equals 0, what does x have to be in order to take 3 times it and get 0? X has to be 0. So that 3 times 0 is 0, which equals 0. Now this is going to be important here shortly, so just kind of keep that in the back of your head, that when we multiply, let's say, move this out of my way here, if we multiply an x and a y together and get 0, which one of these is 0? Because either x has to be 0, so that when we multiply it by y, we get 0, or y has to be 0, so that when we multiply this y times whatever number x is, we get 0. So the key thing is, when we multiply two variables together and get 0, one of these variables has to be 0, because that's the only way we can multiply the two and get 0. We don't care which one it is, but one of them has to be 0. All right, so let's look at example 5 here, and we'll see that in action. All right, so remember earlier when we were factoring these, we didn't have them set equal to 0. We just factored. We weren't looking for what x equals. We were just looking to make this expression simpler by making two parentheses, taking the square root of that term, or we just put 1x in each of the parentheses, because when we did the FOIL, we know that if we wanted to get this back, this number times this number, our first terms had to multiply and give me x squared. Now we have to find two numbers that multiply together that give me negative 24 because of this, and added together give me negative 2. So I end up writing the factors of 24. It's an 8. Okay, so I just keep going there. So the only one that I could get a 2 from would be that, and I'm just not going to do a whole lot of explaining because we've already gone over this and you've already practiced it. All right, so now we have two factors there, or two binomials, two parentheses. Now, if you remember, what I just said is if we have two things that we're multiplying and we get 0, one of these has to be equal to 0, so that when we multiply it by the other one, we get 0. So for instance, if x is 0, it doesn't matter what number y is. It could be 12, it could be 6, it could be any number, because when we multiply it by this 0, we're going to get 0. So that's what we're doing here. We're trying to figure out what number we can put in here to make it 0, and what number we can put in here to make it 0, and that will end up being our answer. So let's go ahead and continue on. So either x minus 6 equals 0, or x plus 4 equals 0. One of those has to be true, because when we multiply this times this, we have to get 0. So one of these parentheses has to give me 0, so that when I multiply it by the other, I get 0. So what does this have to be to make it 0? X, we add 6 to both sides. X has to equal to 6. So that when I put it in here, we get 6 minus 6 is 0. And when we put it in here, we get 6 plus 4. And so now we have 0 times 10 equals 0. That's a true statement. So I have to figure out a way to make that first parenthesis 0, so that when I multiply it by the next parenthesis, I also get 0. So what does this have to be 0? Well, if I subtract 4 from both sides, x equals negative 4. So in order for me to be done here, I need to find out what x is equal to if this were set equal to 0, and what this would be if x was set equal to 0, or if x minus 6 was set equal to 0. Okay, so very important here. I have an exponent of 2. How many answers do you see here? You see 2. And that's pretty much across the board. Now later on, it won't appear that the highest exponent will give you the number of answers you'll get, but it will always be true. So if this was a 4, you would have 4 answers down here, but because it's a 2, you have 2 answers, and that is a quadratic equation right here, is when the exponent is 2. So plan on getting 2 answers here when you solve these. So sorry for the sniffling and fighting the cold here, but one of the things that's really, really important when you're given these equations is before you solve these, they must be written in this format. Have to be in order to solve these. Now, this particular one I have here on the left is from example number 6 on the bottom of page 112. Sometimes we're not given all of the information. Like maybe we aren't given a constant times the variable x. Sometimes we aren't given the c. We always have to have the ax squared if this is a quadratic. And so what we have here, we've got the x squared and the x, but we don't have the term without an x, the c. It's an assumed 0 if it's not there, which means we don't even have to write it. So let's go ahead and put it in this format. So again, we're solving for x. And if you remember, we have been practicing a lot of different techniques in order to simplify so that now, with an equal sign there, we can actually solve what x is. So if you remember, one of the things that we always have to remember is we first of all see if we can factor. And factoring means a lot of different things. In this particular case, it means do we have a term here and a term here that we can factor out of that? Do we have anything that we can factor out of 100x squared? And do we have anything that we can factor out of the 300x? And we do. We have a factor of 100 that we can pull out, and we also have an x that we can pull out, and we're left with an x minus 3. So not too bad. This is old stuff, things that you've done before, factoring out what's common to both of these terms. And in this case, there was 100 out of here and out of here. And my lowest exponent was just an x, so I pulled it out and left the 1 in here. Okay, so now what do I do with this? Well, according to what I had written before, if I say that x times y equals 0, then one of these has to be equal to 0. What I do is I take this and set it equal to 0, and this and set it equal to 0. So I find x twice. So let's find 100x equals 0. Divide by 100, divide by 100, and x equals 0. And then I look at the x minus 3. So I add 3 to both sides. So I have 2 answers here. You will get 2 answers. Remember that. Later on, we'll get to the point where we have to try each of these 2 answers, because sometimes when we put the answer back into the original problem, it doesn't work, but it's still an answer. So for example, if you were trying to find out how many miles you traveled and you got a negative number for one of your x's because you did all the math correctly, you get a negative answer. But logically, distance is never negative, so you know that that answer doesn't work. So just to say, there's going to be some times down the road where you're going to have to consider what's going on there before you actually write the answer down. Okay, so example number 7. Let's look at that. We have x minus 2 and x plus 1 equals 4. All right, so in order to put it in this form, we have to do some tweaking. Instead of being equal to 4, it has to be equal to 0. So the first thing we're going to do is we're going to FOIL this. First, outside, inside, last. Combine like terms. Okay, so we have that. And then the next step, we're not going to do this yet. we have to, before we do that, we have to get this over here. So this is equal to 0. Before we do anything, we've got to set it equal to 0. So I subtracted 4 from both sides. Now I can make my parentheses and make that equal to 0. I put an x here and an x here. Two numbers multiplied together that give me -6, added give me a -1. So I know that it's 3 and 2. Those multiply together to give me -6. So -3 times 2, or 3 times -2. And I have to figure out which one it is, because they both give me -6. But this sign here is negative, so the biggest negative is the pair that I'm going to look at. And that always works there. So, whoops. So don't forget to do that. It makes it easier when you're looking for which numbers work. So the next point is to set x minus 3 equal to 0 and x plus 2 equal to 0 to find out what x is. X equals 3. X equals -2 because we subtract 2 from both sides. So there's my answer. And you are done at that point. Example number 8. 2x cubed equals 5x squared plus 3x. Since we're doing quadratics, and this is kind of a cheater's way of doing it, but since we're doing quadratics, the highest exponent we're looking at is 2. Well, we have a 3 there, so there's apparently something we can do with this before we get started so that our highest exponent is 2. So let's go ahead and set the whole thing equal to 0. So 5x squared minus 2. I'm going to go ahead and do the work instead of just doing it in my head because it might be a little confusing. I'm going to subtract 2x cubed from both sides. So then I get -2x cubed plus 5x squared plus 3x equals 0. Okay? One of the things I don't like is this negative sign here. My leading term has a negative sign because I'm doing it in decreasing order, 3, 2, 1. And with that there, that causes me problems. So here's what I'm going to do for this. I'm not going to explain the whole method, but what I'm actually doing is factoring out a negative. So what I'm doing is I'm just changing the sign of everything on both sides of the equation, and it's good. And when you change the sign of 0, nothing happens. So now it changes to positive, but notice I changed this sign and I changed this sign, which is perfectly legal to do. What do I have common between those two, or those three terms? I have an x that I can factor out. Okay, and next thing I'm going to do is I'm going to factor this, and you've done this before, so I'm not going to go into a lot of detail. The x carries along with me, and I get 2x plus 1 and x minus 3. Okay, so again, I'm going to leave that alone. Okay, let me say this before I continue on. In our original equation, notice we have an x cubed. That means I'm going to have 3 answers when I'm done because of that x cubed. So just remember that. So let's go back and look at where I'm at here. So what's going to happen? Either the x equals 0, 2x plus 1 equals 0 from here, or x minus 3 equals 0. So there I got 1, 2, 3 different options for x. X equals 0. Don't have to do any work. It's done. X equals 0. 2x plus 1. I'm going to subtract 1 from both sides. I'm going to divide by 2. And x equals -1/2. And then here I'm going to add 3, x equals 3. So I have 3 different answers for example number 8 on page 113 because my leading term has an exponent of 3, so I know I have 3 answers. All right, so we have 1, 2, 3 more examples, so I'm just going to go ahead and make a new video, so it'll be called 2.1c.